Hey guys, I hope your quiz went well. We are going to dive right into section 3.3. So on your quiz, you started your justifications, hopefully, with if parallel lines are cut by a transversal, then whatever kind of angles are either congruent or supplementary, right? We did that fill in the blank almost. Well, now in section 3.3, we're actually going to prove that we have parallel lines because of these special angle pairs. So this first one we're going to talk about is corresponding angles. So if we have two coplanar lines, so coplanar, that are cut by a transversal, so that the corresponding angles are congruent, then the two lines are parallel. Right? So if you look at it, it is almost the exact opposite of what we did before. Before we did, if we've got these parallel lines, then the corresponding angles are congruent. So now we're doing the opposite. We're saying, hey, if we've got these corresponding angles that are congruent, then we can say that these lines are parallel. And we can do the same for all of these different angle pair relationships that we were talking about in section 3.3. Pretty cool, right? So take a look at the next one. The next one is our alternate interior angles theorem. So again, two coplanar lines are cut by a transversal so that a pair of alternate interior angles, and we can abbreviate, alt-int is fine, alternate interior angles are congruent, then the two lines are parallel. We can shortcut there too. And then let's talk about our other ones. What do we have? Two coplanar lines that are cut by a transversal so that a pair of alternate exterior angles, so this is transversal, Miss J, so that a pair of alternate exterior angles, so alt-ext, alternate exterior angles are congruent, then we've got our parallel lines. And if we have two coplanar lines cut by a transversal so that a pair of same side interior angles are supplementary, remember same side sup, then we will get the two lines are parallel. And then the last one is actually filled in for you already. If two coplanar lines are cut by a transversal so that same side exterior angles are sup, then we can get those lines to be parallel. So again, now we're starting with the angle pair relationships and saying, hey, cool, that gives us parallel lines. Before, we started with parallel lines and used that to get these angle pair relationships. So it's a little backwards of what we were doing in section 3.3. But let's go ahead and take a look at some of these examples here. So determine whether the following lines are parallel and explain your reasoning. Hey, check that out. We're going to justify again, just like we did in the last section. So when we look at these two lines, we're trying to decide if M and N are parallel to each other. Well, we know for sure that this line T has to be our transversal, because that helps make up both of these 40-degree angles. So when we look at those, we can see that they're alternate interior angles. Alternate interior angles, Miss J. And they are congruent to each other, which means, yes, we can say that these lines are parallel. Ready for our crazy explanation for this one? I think you guys will like it better. It's not quite as wordy as the other one. If alternate interior angles are congruent, then parallel lines. So again, we're not starting with parallel lines here, so we don't want to say if parallel lines, then alternate interior angles are congruent. We're trying to prove the parallel lines. So we have to start with the fact that we know that the alternate interior angles are congruent, and then say, hey, that means I get my parallel lines. Cool? All right, number 2. Well, when we look here, we've got this angle SKM and this angle QLR. And when we look at those, we can see that this line SR is our transversal, and those two are both on top of my transversal and outside, which means these are same side exterior angles. Well, if we're trying to prove, oops, move it over, Miss J. If we're trying to prove that these lines are parallel, we want those to be supplementary to each other, which means I want to see if 146 plus 44 gives me 180, and it actually doesn't. It gives me 190 degrees, which means no, these ones are not parallel. And you do still need to give me an explanation, but this one's not going to be in an if-then format. For this one, we can just say that the same side exterior angles are not sup. So same side exterior angles are not sup. And they are supposed to be. They're supposed to add to 180 if I have parallel lines. So since these ones don't, it clearly means that those two lines are not parallel to each other. All right. Let's take a look here. I'm actually going to have you guys do 3 and 4 on your own. All right, so give those a shot. We will talk about them when you guys are in class with me. Let's jump down to question 5 down here, the bottom of page 26. All right, so use the given information and the converse postulate or theorem to show that line M is parallel to line N. So they're telling us that angle 1 is congruent to angle 3. If I look at angle 1 and I look at angle 3 and I mark those angles there, I can see that they're corresponding angles, and they're telling me that they're congruent. So that's actually what I'm going to start with then. I want to start with if corresponding angles are congruent, then parallel lines. That's it. They told me that 1 and 3 are congruent. I see that they're corresponding, so I just put that in there. If corresponding angles are congruent, then I get my parallel lines. Then I want to look, now they're telling me the measure of angle 6 plus the measure of angle 7 is going to be 180 degrees. So they're telling me that these two orange angles that I just marked are supplementary, and those are same side interior. So my postulate that helps me here is if same side interior angles are sup, then parallel lines. And it's as easy as that. Let's take a look. Hopefully this looks familiar. You guys did just do the mathematical practice assessment for quarter 1 the other day. So this is very similar, right? We're going to take a look at this one now. So use the given information and the converse postulate or theorem to show that line M is parallel to line N. So the first thing that we have to look at here is what are we given? Well, we're given the measure of angle 2 is 25x minus 3. And the measure of angle 8 is 10x plus 8. So the first thing I always think to myself is, okay, what kind of angles are those? Well, it's quite clear that they both share this line right here, which means this line is my transversal. They're on the same side, they're outside of lines M and N, so it's clear to me that angle 2 and angle 8 are same side exterior angles. Same side exterior angles. And that's going to be helpful to me because I need to figure out what they are and actually see if they are supplementary like they're supposed to be in order to prove that these lines are parallel. So I'm going to first find the measure of angle 2. So the measure of angle 2 I know is 25x minus 3. And I forgot to point this out up here, but hopefully you read it. X equals 5. So let's just plug it in. So 25 times 5 minus 3, that means the measure of angle 2 is 122 degrees. So that's cool. I got that. Measure of angle 2 is 122 degrees. And then I want to find the measure of angle 8 and see what that is. So the measure of angle 8 is, you cannot see, my bad. Measure of angle 8 is 10x plus 8. So 10 times 5 plus 8. So the measure of angle 8 is 58 degrees. And we said that these two angles are same side exterior. So if we're trying to prove that line M is parallel to line N, we have to show that these are supplementary. So let's actually see if that's true. Measure of angle 2 plus measure of angle 8, we want that to equal 180 degrees, right? That's what we're asking ourselves here. So let's see if it's true. 122 plus 58. And hopefully you guys agree with me, but it is 180 degrees, which means measure of angle 2 and sorry, not measure of angle 2. Cross that off. Ignore me. Don't write what I just wrote. How about this, Miss J? Angle 2 and angle 8 are sup because they add to 180 degrees, right? And so we can get that line M is parallel to line N. All right. So now we're going to write up our explanation here. So the first thing we did was we had to substitute the x in for the 5 in for x, right? So first substitute x equals 5 into the given angle measurements. Into the measures, into the given angle measures. I can speak today, guys. Second, we had to simplify the expressions to find measure of angle 2 and the measure of angle 8. Right, so remember when we do these explanations, we always have, okay, this is what I did and this is why. Right, so we started out with substituting, and now we're simplifying so that we can find the measure of angle 2 and the measure of angle 8. And then we know that line M is parallel to line N because, right, there's our important word always, is because. And why did we say that they're parallel? Well, if we look, we had same side exterior angles. So if same side exterior angles are sup, then we get parallel lines. So then parallel lines. That's really the big key right here. This one's not quite as step-by-step as some of the other mathematical practices that we do, but this is kind of getting us into the idea of proofs, which we're going to cover later in our class. But that is how we do it. All right, make sure that you've got the because, make sure you've got if same side exterior angles are sup, then parallel lines. All of that is really important information, okay? There is one more for you guys to do on page 28, but I think you guys can do it without me, all right? If you watched this video, you should be able to. So when you come into class tomorrow, I will be checking numbers 3, 4, and 8. All right. If you have questions, make sure you stop into the MRC or at least jot them down so that we can talk about them in class. But I will see you guys then. Bye.